Hello friends, how are you? I hope you all are well. Today in this video, I am going to explain about wheatstone bridge, which is one of the important application of Kirchoff's law. Okay. So what is this wheatstone bridge? In fact, it is an arrangement of four resistors. Four resistors. Here I have mentioned its resistance P, Q, R and S. Out of that four resistors, we can measure resistance of one of them in terms of the others. That means if the three resistors resistance are known, we can find the resistance of the fourth resistor. So I can say that it is an arrangement of four resistors. Arrangement of four resistors or resistances. Okay, which can be used to measure one of them in terms of others. Okay, so see this diagram, how it is constructed. Four resistors are there. The resistances are P, Q, R and S. A, B, C, D, four junctions are there. Junction A and C are the opposite junctions, are connected with a battery. Junction B and D are connected with a galvanometer. You know that the galvanometer function is to indicate the presence of current. Here there is a needle in this galvanometer. If there is a flow of current, the galvanometer will deflect either left or right. Suppose it is reflecting left. Now I shall reverse the battery. That means it will deflect right. So there is no doubt that current will flow through the galvanometer. But when the current is flowing, that time we say the bridge is in a unbalanced condition. To find the resistance of the unknown resistor, we have to bring this bridge to the balanced condition. Balanced condition means the time when there is no deflection in the galvanometer. So I can say that its principle is that principle of the wheatstone bridge. It works on the principle of non-deflection. That means that is the ratio of their resistances are equal in balanced condition. In balanced condition means when there is no deflection of a current, that time the ratio of the resistances will be equal. It can be P divided by R equal to Q by S, or P by S equal to R by S, or you can say PS is equal to QR. How it is possible? I am going to explain the working of a wheatstone bridge. This is the construction. Why it is called a bridge? You see that its appearance is looking like a bridge. This wheatstone bridge is also called, I can say that this is the resistor bridge. So here four resistors are arranged in a systematic manner. You can see it. Now let us come to the point how to find the resistance of the unknown resistor. Here I said that P and Q are the two inbuilt resistors. That means its resistance known to us. This R is a variable resistor and S is a unknown resistor. So this P and Q, these are the inbuilt. So this R is variable resistor, okay, and S is unknown. Out of 4 resistors, any one resistance we can find, if the remaining 3 are known to us. So at first we have to see the balanced condition. So how it is possible? We have to adjust the rheostat, variable resistor. So definitely one stage will come when the deflection of the galvanometer will become 0. Now let us see. Suppose from this cell the I ampere of current is coming. Now the current reached here at the point A. From this point A, the current is divided into I1 and I2. From junction law, we know that the amount of current entering into junction also equal to amount of current leaving the junction. That means from here the I is divided into I1 and I2. Suppose the current entering through the galvanometer, that means this arm is called the galvanometer arm. These are the resistor arms. A to C is called the battery arm. Now the current entering through the galvanometer arm, let it be I3, and here suppose it is I4. Okay, see that I1 entered here, to this side it is going I3, so ultimately this I4 is equal to I1 minus I3. I1 reached here, I3 went this side, so definitely this side will be I1 minus I3. To this junction D, amount of current entering from this side is I2 and from this side it is I3. That means suppose this current is I5, okay, this direction. This I5 definitely this is I2 plus I3. Now you see that at this junction I1 minus I3 plus I2 plus I3. That means I3 cancel, I1 plus I2. That means here is I1 plus I2 which is equal to I. That means we should keep care that however the amount of current leaving the battery should be equal to amount of current entering into the battery. That means it left I and entering also I amount of current. That means what we have taken, that is absolutely correct. See here. Now we will adjust the rheostat in such a manner, however the flow of current to this galvanometer will be equal to 0. So that means in balanced condition. So I can say that in balanced condition, I3 is equal to 0. If I3 equal to 0, I can say that I4 is equal to I1 minus I3. This is equal to I1. That means I4 becomes I1 since I3 is equal to 0. Similarly, this I3 became 0. So what about the I5? This I5 is equal to I2 plus I3 is equal to I2. So I can say this is I2 since I3 is equal to 0. It is a matter in balanced condition. Okay. Now let us see. In balanced condition, the potential at the point B also equal to potential at the point D. So I can say that potential at the point B is equal to potential at the point D. That means potential difference between B and D is equal to 0. This is the balanced condition. B and D potential same, so potential difference 0. That's why no flow of current. That means the bridge is in balanced condition. Now let us see. Here I can say that the potential difference between A and B. See that potential difference between A and B. I can write potential at the point A minus potential at the point B. Potential at the point A minus potential at the point B. So how much it is? V equal to IR according to Ohm's law. That means this is equal to I1P. So I can say this is equal to I1P. Now see that potential difference between B and C. So VB minus VC. This is equal to I1Q. I1 is the current, Q is the resistance. Okay. Similarly, I can say that VAD is equal to VA minus VD is equal to I to R. Similarly, I can say that VDC is equal to VD minus VC. This is equal to I2 into S. I2, this is I2S. So this is the first equation, second equation, this is third equation, this is fourth equation. Now let us see. I said that VB and VD both are equal. VB is equal to VD. Okay? In balanced condition. If VB equal to VD, in place of VB, I can write VD. Here also I can write VD. Okay? Now you see that. So in this case, equation 1 and 3 both are equal. How? VA minus VD, this is also VA minus VD. So I can say that I1P is equal to I to R. And similarly, I can say that the second and fourth are equal. How? VD minus VC, this is also VD minus VC. That means I1Q is equal to I to R. Or I can say that I1 divided by I2 is equal to R by P, and I1 by I2 is equal to R by Q. That means this is I1 by I2, this is also I1 by I2. So I can say that R by P is equal to, this is PR, I1 by R2, R by P. This is I to S, by mistakenly written I to S. So I1 by I2, this is equal to S by Q. See here, I1 Q, this is I to S. So I1 by I2, S by Q. So this is R by P, that is S by Q. That means both are I1 by I2. So I can say that R by P is equal to S by Q, or implies that PS is equal to RQ. This is the balanced condition. Suppose this S is the unknown. That means I can find that S is equal to QR by P. We got the resistance of the unknown resistor S. So PS by PQ, PS equal to RQ. This is the balanced condition. So you can remember like this, P into S is equal to R into Q. So this is about the wheatstone bridge. So in this bridge, 4 resistors are connected. Out of that 4, 2 are the inbuilt. That means already it is fixed there. And this is a variable resistor. We can vary by varying the resistors or resistance. we can bring the null deflection in the galvanometer. When the galvanometer is null deflection, that means the stone is in balanced. If there is a current, it is unbalanced. If there is no current, no reflection, that means it is in balanced condition. So in balanced condition, I can say that P into S is equal to R into Q. This is the condition for the balanced condition. This is the balanced condition. This is the balanced condition. So we got the resistance of the unknown resistor R. I hope that you might have understood this video. So in my coming video, I shall explain about the other application, that is the meter bridge, and also I shall discuss about the potential meter. Until then, bye.